In this video, we will work on this problem. This is from 2018 JEE Advanced Paper 1. So let us look at the thinking strategy. First, read the problem carefully and visualize what is happening and identify the keywords and phrases. So if you read the problem, you will understand block 1 kilogram is moving to the right with a speed of 2 meter per second. It will collide with block 2 kilogram, and after that, if you know about elastic collision, you will know beforehand, before solving it, that 1 kilogram will bounce back and start moving to the left, while 2 kilogram will compress the spring and it will start an oscillation. And keyword, it says frictionless. That means the speed of 1 kilogram will not change as it is moving left or right, and 2 kilogram will keep oscillating without any damping. The goal is to find the distance between 1 kilogram and 2 kilogram after 2 kilogram comes back to its original position after impact the first time, right? So the first thing you need to solve is when the spring will return to its unstretched position for the first time, and during that time where 1 kilogram has reached. So if you solve for when and where M1 is after that time, then you will get your answer. So this is how you plan, you strategize your thinking. You find out what you need to solve. Now, let us look at 2 kilogram block. We will call it M2. So it will start oscillating as you see in the red path, right? Oscillating back and forth. So what you have to find out time. If you look at the yellow highlighted area, right, after the impact, so M2 is here. Before impact, after the impact, it will compress the spring, move to this position, stop, then the spring will push it back, and then M2 will get back to its start position, and that's when the spring returns to its unstretched position for the first time after the collision. That is half time period, right? Half cycle. So time can be related to time period of oscillation, which is related to frequency, which is square root k by m. And if you do your calculation, right, k is 2 Newton per meter, m2 is 2 kilogram, you will get time period of 2 pi seconds, and half time period is pi second. You found when, right, m2 or spring will get back to its unstretched position. Now, during that time where M1 has reached, to solve that, you need to solve impact. So before impact, you know it is given. After impact, let's say M1 is moving with the speed V1, M2 is moving with the speed V2. Momentum is conserved, right? And elastic collision, that means speed of separation after the impact is equal to speed of approach. And you apply these simple principles and you will get speed of M1 after impact is to the left 2 by 3 meter per second. So in the figure I draw arrow to the right, so that is why we get a negative answer. Now see, we found when pi seconds, and in that time period M1 was traveling to the left with a speed of 2 by 3 meter per second. So the distance between M1 and M2 will be speed multiplied by time. The answer is 2 by 3 meter per second. That is your answer, right? Now let's look at an important thing, the trap. In this problem, if you do not use time period and frequency and you start solving for the time, how long it will take for M2 to get back to its start position, right? And you start using the M2 velocity, which is sine function, and you start integrating, that will take much longer. You will lose a lot of time. So to do it efficiently in around 3 minutes in the exam, you need to know the tricks, like catch these small things, like that time can be calculated directly from frequency. So you have to strategize your thinking like that. And that's how we have completed the problem. And please give your feedback so I can improve my videos in future.